If you're running production workloads in Azure and you can't answer the question what traffic hit my network in the last hour, you're flying blind, and I've seen that blindness cost companies six figures in breach response costs.
Okay, that's terrifying. What do you mean by flying blind exactly?
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and today we're diving into Azure Virtual Network Flow Logs with my co-host who's been asking me about network visibility all week.
Hey everyone. Yeah, I've been trying to figure out how to actually see what's happening in my Azure networks, and it's been confusing.
Perfect timing then, because today we're going to demystify flow logs and show you how traffic analytics turns raw data into actionable security insights.
So let me set the stage here. I deployed a web application in Azure, everything's working fine, but my security team keeps asking me questions like what IPs are connecting to your VMs, and are there any suspicious traffic patterns, and I honestly have no idea how to answer them.
That's the exact problem flow logs solve. Think of it this way. Your network security groups are like security guards at building entrances. They check IDs and either let people in or turn them away. But here's the thing. A security guard who doesn't keep a visitor log isn't very useful for investigations, right?
That makes sense. So flow logs are basically the visitor log that records everyone who tried to get in, whether they succeeded or not?
Exactly right. Now, I should mention that Azure actually gives you two options here. The original NSG flow logs, which capture traffic per network security group, and the newer virtual network flow logs, or VNet flow logs, which capture traffic at the virtual network level. For most new deployments, Microsoft recommends MET flow logs because they're simpler to manage and give you more comprehensive coverage.
What's the difference in practice?
With NSG flow logs, you have to enable logging on each NSG individually, and you only see traffic that actually hits an NSG. With MET flow logs, you enable it once per virtual network and you capture traffic even when there's no NSG associated with a subnet or NIC. It's less configuration and fewer gaps in visibility.
That sounds way easier. What data do these logs actually capture?
Both capture what's called the 5-tuple: source IP, destination IP, source port, destination port, and protocol. But version 2 flow logs, which you definitely want, capture much more than that. You get the traffic decision, whether it was allowed or denied, the flow state showing whether the connection is beginning, continuing, or ending, byte counts and packet counts in both directions, and timestamps. It's really rich data for analysis.
Okay, so where does this data actually go? And how do I turn it on?
You enable flow logs through Azure Network Watcher. Good news is that Network Watcher is automatically enabled these days when you create or update a virtual network in a region, so you usually don't need to worry about that step anymore. The logs get stored in an Azure storage account you specify. In the portal, you navigate to Network Watcher, then Flow Logs, and create a new flow log. For VNet flow logs, you target your virtual network. For NSG flow logs, you target individual NSGs. Make sure you select version 2 to get all that throughput information I mentioned.
Got it. But here's my concern. If I have lots of connections per minute, aren't these logs going to be massive and impossible to read?
You've hit on exactly why raw flow logs alone aren't enough. A busy virtual network can generate gigabytes of JSON data daily. The logs are written to storage in 1-minute aggregation intervals within hourly blob files. Trying to manually parse that to find anomalies is like trying to find a specific conversation by reading every text message sent in a city.
So what's the solution? You mentioned traffic analytics earlier.
Traffic analytics is the game changer. It's a feature you enable alongside flow logs that sends your data to a log analytics workspace. Here's what it does. It processes those raw flows, enriches them with geographic data and Azure-specific context, and then applies analytics to surface patterns. It can tell you things like you're receiving traffic from 47 countries, but 90% of denied traffic is coming from 3 specific IP ranges.
Oh, that's powerful. So it's doing the analysis work for me instead of me writing queries against raw JSON?
Exactly. And it visualizes it too. You get a geomap showing traffic sources, graphs of allowed versus denied flows over time, and most importantly for security, it identifies potentially malicious traffic patterns. For example, it flags things like port scanning behavior, where a single IP tries to connect to many different ports on your resources.
How does it know what's malicious versus just unusual?
Great question. Traffic Analytics uses Microsoft's threat intelligence feeds. It cross-references source IPs against known malicious actors, botnet command and control servers, and other indicators of compromise. If traffic from a known bad IP hits your network, even if it's denied, Traffic Analytics flags it. You can see this in the malicious traffic section of the dashboard.
What about something like Tor traffic? Is that automatically flagged as malicious?
That's a common misconception. Tor exit nodes aren't inherently malicious, and traffic analytics doesn't flag them just because they're Tor nodes. However, if a specific Tor exit node has been involved in malicious activity and appears in Microsoft's threat intelligence feeds, then that IP would be flagged. It's about known malicious behavior, not just the use of anonymizing services.
What about anomalies that aren't from known bad IPs? Like if someone inside my network starts behaving strangely?
This is where you combine traffic analytics with custom KQL queries in log analytics. The data lands in the entNate analytics table, and there are related tables like entAt topology details and enttype details for specific data. I'd recommend checking your workspace to verify the exact table names since Microsoft has been updating the schema over time. You can write queries like show me any internal IP that suddenly started communicating with 50 or more unique destinations in the last hour when it normally talks to 5. That's a potential indicator of lateral movement or data exfiltration.
Can you give me a specific example of what that query might look like?
Sure, you'd query entNate analytics, filter for allowed flows, then use summarize to count distinct destination IPs by source IP over a time window. Compare that to a baseline you've established. If a VM that normally connects to your database and a few Azure services suddenly reaches out to hundreds of IPs, that's worth investigating.
This is really clicking now. What are the common mistakes people make when setting this up?
The biggest one is enabling flow logs but forgetting to enable traffic analytics, then wondering why they can't see anything useful. The second mistake is about the processing interval. When you configure traffic analytics, you choose how frequently it processes your flow log data, either every 10 minutes or every 60 minutes. For security monitoring, you want that 10-minute processing interval so anomalies surface faster. The underlying flow logs in storage are still aggregated in 1-minute intervals within hourly files, but the processing interval determines how quickly you see that data in traffic analytics.
Any other gotchas?
Watch your log analytics data retention settings. The default retention depends on your workspace configuration and pricing tier. For pay-as-you-go workspaces, you can configure interactive retention anywhere from 4 to 730 days. For security investigations, you often need to look back further than the default, so explicitly set your retention policy based on your compliance and investigation requirements. Also, if you're still using NSG-flow-logs instead of vnet-flow-logs, remember that they're per NSG. If you have NSGs at both the subnet and NIC level, you need flow logs on both to get complete visibility. That's another reason vnet flow logs are easier. One configuration covers the whole virtual network.
Okay, let me make sure I've got this. Flow logs record all traffic in my Azure virtual networks. I can use either NSG flow logs per security group, or the newer vnet flow logs per virtual network, with vnet flow logs being the recommended approach. I store them in a storage account, but the real power comes from enabling traffic analytics, which sends that data to log analytics, enriches it with threat intelligence, and surfaces anomalies automatically.
Perfect summary. And my pro tip, set up Azure Monitor alerts on the traffic analytics data. Create an alert that fires when malicious traffic detections exceed 0 in any hour. That way you're not just logging, you're actively monitoring.
This is exactly what my security team has been asking for. I'm setting this up today.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone running production workloads in Azure who needs better network visibility.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.